So in the previous section, we introduced lenses as devices that bend light to form images. So this begs the question, what types of images can we use lenses to form? Well, there are three basic ways that we're going to distinguish between the types of images we have. And so the first question we'll ask is the image real or is it virtual? And there are a couple different ways to frame this one. But a real image is an image that's formed when the light rays from the object intersect at the location of the image. So what this means is you could see the image. Why it's known as a real image is that you could see it by putting a screen at the position where the light rays intersect and see the image right there on the screen. It's real. What we'll see is there are situations where instead of the rays intersecting each other, what will intersect, and so where the image will form, is the projection of those rays back on to the object side of the lens. And so when that happens, we have what's known as a virtual image. So you can't put a screen there to see that image, because if you tried, you'd basically block the light that's trying to come through the lens in the first place. Virtual images are images that form on the object side of the lens. And so that's why instead of the rays coming through the lens and intersecting to create a real image, we have to project those rays back to see where they intersect on the object side of the lens. The second question we can ask is the image enlarged or reduced? And this one's a little bit more straightforward. An enlarged image is simply one that's larger than the object, and a reduced image is one that's smaller than the object. So we'll be able to look at our object height, look at our image height, see whether or not the image height is larger or smaller than the object. That'll tell us whether or not our image is enlarged or reduced. So our third question is whether or not the image is upright or inverted. And just like the last one, this one's a little bit more straightforward than the first. An upright image is oriented in the same direction as the object. So we will typically orient our objects in an upright way. So our object will point up, and an upright image will also point up if we're drawing our objects as arrowheads. An inverted image, of course, is one that's oriented in the opposite direction. So that arrow pointing up to signify our object turns into an arrow pointing down in our image. That's an inverted image. Those two arrows are now pointing in the opposite directions. So as you might have guessed, these definitions are related to our sign conventions. So if I want to think about a real image, well, the easiest way to identify a real image is to see that it has a positive image distance. It's an image that forms on the image side of the lens. A virtual image, on the other hand, is an image that forms on the object side of the lens. So it's going to have a negative image distance. For our enlarged versus reduced and upright versus inverted, there I need to think about the image height. And in the first case, I want to compare the image height to the object height. So an enlarged image has an image height that's larger than the object height. A reduced image has an image height that's smaller than the object height. For upright versus inverted, I simply need to think about the sign of the image height. So if the image height is positive, then it's an upright image. If it's negative, it's an inverted image. What we want to do is get comfortable with both interpreting what our calculations tell us in terms of the sign conventions, so whether we have a real versus virtual, enlarged versus reduced, upright versus inverted image, by interpreting what our values are when we work the problem. We also, of course, want to be able to sort of look at what's going on in our picture and recognize whether we have real or virtual, enlarged or reduced, upright or inverted images. So let's look at an image formed by a convex lens. And so again, here's our object over here, and it's initially oriented upright. There are three rays that we've drawn in that show where the image forms. And of course, part of what you see is this image forms at the intersection of those three rays. So when I think about what kind of image this is, the fact that I know it's an image that formed where the rays actually intersected means that this must be a real image. Of course, I also know that this is a real image because the image formed on the image side of the lens, so the side where the light goes out, which means that the image distance is positive. So all of those are ways of recognizing that this is a real image that's formed by this lens in this particular configuration. If I want to think about whether or not the image is enlarged or reduced, well, that's basically saying compare this length to this one. And what you can see from looking at the picture is that the image height is a little bit less than the object height. It's not the easiest thing to see because they're relatively close to each other, but the image height is a little less than the object height, and so this is a reduced image. In terms of whether it's upright or inverted, well, obviously here the fact that it's flipped over tells me it's inverted. And so again, that's consistent with my sign convention that says that if I have an image that points below the principal axis, then that image height will be negative and it's an inverted image. So in this particular case, my convex lens formed an image of this object that was real, reduced, and inverted. Let's look at a second example with our concave lens. Same situation, so I've got an object sitting over here. I've drawn in these three rays, and I see where it forms an image. And so I want to go through the same process, asking what kind of image is this? And so my first question is this a real or a virtual image? There are a couple ways I can answer this. The easiest one is to recognize that the image has formed over on the object side of the lens. That means that the image distance will be negative, and so this must be a virtual image. The other way is notice that this point where the image forms is not where these light rays actually all intersect. It's the projection of two of these rays to intersect with the third that is actually where this image forms. So that's another thing that's telling us, because we can't put a screen here. This isn't where the light rays actually intersect. If it was, we could put a screen there and view the image. Because this isn't where the light rays actually intersect, it's where they project to intersect back on the object side of the lens. I can't put a screen here to see this image. It's a virtual image. Was this image enlarged or reduced? That one's easy to see in this case. It's clearly reduced because it's much smaller than the object. And is it upright or inverted? Well, again, if the object points up, the image points up, then this is a upright image. And that tells me that the image distance is both less than the object distance, and both of those in this case are positive.